Today, we're going to talk about another way to display quantitative. So not categorical, okay? So not males, females, not traits like romantic, wise, not displaying categorical data, but we are into the displaying quantitative again. What's one way that we've already displayed quantitative data? What's one way we learned how to display? Box plot. Good. Our box and whisker plot had quantitative data in our orders. Okay, very good. So here's another way, a stem and leaf plot. So that's what we're going to do today, a stem and leaf plot as well as a dot plot. Okay? So with a stem and leaf plot, it might look something like this picture here. Could you close that door, please? Thanks. And so this area would be your stem, and this area would be your leaves, and each one of these leaves represents a piece of data in your set. For example, this first number, 0.00, is this number 0.00 in the data set. Each leaf is its own number. So 0.01 is this next piece of data, 0.01 and 0.09. So these first three pieces of data are the ones that are in that row right there. Okay? So the good thing about a stem and leaf plot is you can see every single individual piece of data. You can also see, like here's the maximum, 0.82 is that little guy right there, 0.82. Now, one thing that is missing here that we're going to do is a key. Whenever you do a stem and leaf plot, you always want to do a key so you can see what these items are representing. So let's go ahead and fill one of those in. So somewhere where you have room, we're going to write key, and you can pick any number. So I'm going to pick 0.2, and then I put the vertical line to represent the difference between the stem and the leaf, and then I'm going to have the number 4. Then I'm going to put equals, and what does that represent? 0.24 is what that represents, and I want to include context. Okay, so 0.24 centimeters of daily growth, because that's what it had talked about in the paragraph up above. Okay, so with my key, I want to include the context. All right. And so now I know what each one of those pieces of data represents. Okay, moving on. So some of the advantages one other thing to notice is that, do you see how if there are repeats, they are all listed? Also notice that these numbers go from least to greatest. With the stems, or the leaves go from least to greatest, and repeats all get listed. Okay? And finally, I want you to notice that it isn't just because of the typing that these things are all nice and organized neatly. You do want to give each one their own correct space so that it is drawn to scale. Because if it looks bigger than you want, it's because it holds more values. So make sure that each of these, columns also, each number is getting its own amount of space, okay? Because it has to be drawn to scale as well. Okay, so benefits. The advantages of the stem and leaf plot is that you can see all of the original data. That's a good thing, because then you can find all the different, you can find the 5-number summary very easily. And what are the things in the 5-number summary, by the way? Men, let's do it in order. Men, Q1, median, Q3, and max. Very good. So you can find all of those values very easily with the stem and leaf plot. All right. Now there is something wrong here in this next statement, and so I want us to talk about it. It says ease of transferring or translating it into a bar graph, histogram, circle graph, box and whisker plot. A bar graph is not appropriate because a bar graph is for categorical data. A bar graph is for categorical data, not this kind. What kind of data is this? Quantitative. So, for example, a bar graph would be something where you have a space in between the bars because the order of them doesn't matter. Like that's blue, red, yellow. And like our board over there, do you see how each bar has a space between them? They are not a continuous numerical value. So these cannot translate into a bar graph. They can go into a histogram, and we'll talk about that later in this chapter. Okay. Some disadvantages are that if you have a lot of numbers, it can be very cumbersome. And we're going to see that in a minute. Another thing that we are just about to see with this example here is that if you have a very small range of data, it can be difficult to break it into meaningful or to know how to break it into meaningful sections. So we're going to take this set of data here and we're going to make stem and leaf plot, and I'm going to have half of the class do it one way and half of the class do it the other. So let's first talk about the ways that we're going to do it. First of all, these numbers range from what? What's the lowest value? 12. To the highest value? 48. Okay, so I see 48 is the largest. Okay, so in a moment, and don't write this down because some of you will do this way and some of you will not. In a moment, I'm going to have half of the class do these 4 stems like this and then write your data in that way, okay? And then you'll do that out. But I'm going to have the other half of the people do this because there actually are, I can see that there are a lot of numbers in the teens, and so it could be, and also a general rule of thumb is to have 5 to 10 stems. So to have 5 to 10 stems is better than 4 if you can break it up easily that way. So in a moment, half of you are going to break this way. 1, 1. You're going to split the stem. 2, 2, 3, 3, and 4, 4. So as a class, let's discuss what will be going into each one of these sections here so that when they do that, those people know what goes in each section. Okay, so think about it. I got the ones broken into 2 sections. So what will go in the first section of the ones? The numbers 10 through 14, because that represents 5 digits worth of values. What numbers would go in the second set of ones? 15 through 19. That also is 5 sets of digits. When you do your bins, your stems, you can't have different amounts in each one. I can't split the 1s and then not split the 2s or the 3s. If you split them, then you have to split them all, because every bin that is equal width has to have the same amount of digits in there. Okay, so let's split this class up. Let's have this row by the board out to there, and then you 2 guys back there. Let's have y'all all do this first method over here on the left, okay? And make a key also. And let's have the rest of the class organize your numbers like these ones over here on the right.
Is a key just one example?
Yes, a key is just one example. So you just pick one of them, any of them, and make a key.
Oh man, these aren't even in order.
They are not in order, so that's another reason why when you have a large set of data, it can become very cumbersome. Okay, so let's take a look at these 2 separate ways of how to do this. Okay, those of you who did this one on the left, were you not thinking, holy cow, there's even more numbers? It's just like forever and forever and forever. Look at all of these, okay? So that was pretty cumbersome there, trying to get all of those numbers into that one. It's more information if we have it split up this way. That was better. Okay? Now, notice that we had this little gap here. What did that gap right there mean?
It means there was no numbers.
Good. We had no numbers between 30 and 34. Okay, and so on, so you got to watch that. Okay, and make sure you included a key. I happen to use the number 23, but you could use any of the numbers. It's fine. So, could we determine, the questions it asks, could we determine how many people attend the meeting? We can count them all, and there are 34 because we have how many individual ones? From our stem and leaf plot, could we determine the youngest and the oldest?
Yes.
Youngest is?
12.
Oldest is?
48.
Good. And that is because our stem and leaf plot preserves the individual pieces of data. That's the good thing about it. How about which age group was most widely represented?
15 through 19.
Good. It's better to say, you know, the later teens, 15 to 19. So that's more informational than just saying teens, because we can say, you know, the upper teens or the 15 through 19. So that's another reason why splitting it can give you better specific information. Okay? But again, I've split it because 4 stems is not ideal. Typically, we want 5 to 10 stems. 5 to 10 stems. Okay, let's take a look at this next one. This next one is a double stem and leaf plot.
Oh my.
And so look at, this one is already done for you because I figure you could put those in there. But what's good about a double, what will the benefit to a double stem and leaf plot do for you?
It's kind of like a bar graph. Double bar graph.
Different.
It can compare two pieces of data, 2 sets at the same time. Okay, so here, this is a teacher's grades that she gave to the AP Statistics students in 2009 and 2010. So we can compare side by side and see, is there a difference in the distribution? You know, did maybe one year have a lot more higher grades than another year? Now, I want to make sure you know how to read this, and we're going to make a key for it. So that, of course, means a grade of what in 2010? Okay, very good. Now, here's the key. Here's the catch here. Let's check this one right here. You see this one I'm circling? This is a grade of what? That is a grade of 76, not 67. You read from the stem out. So that is a grade of 76, not 67. Furthermore, I want you to notice that the grades are in order from least to greatest from the stem. So do you see on the right side, they go from 0 out from the stem. Do you see on the left side, the smaller numbers are near the stem and they get bigger as you go away from the stem. So the smaller numbers are near the stem. All right, so let's make a key for this. So let's just kind of demonstrate how you would do that. So I'm going to pick that value. I'm going to go 6, 7, 0, and I'm going to put what that equals. So that equals a 76 points for a 2009 student. Okay, and that also represents a what?
70.
70 points for a 2010 student. Okay, so that's how you would identify the key to this information so people know what it is representing. Okay? Questions there? All right, moving on to the next one. You are now going to make a double stem and leaf plot, but it has a lot less numbers. So this is about the minutes that it takes to get your Starbucks or your Just Us coffee. And I sure hope that these are not real numbers because these go from 8 minutes to 29 minutes.
For coffee,
Okay?
that's a little cray-cray.
So for coffee, that's right, that's a little cray-cray. I'm thinking I need my caffeine faster than that.
Yeah, I'm definitely
getting a little-
it'd be more accurate if it was like 2.
Okay,
For coffee?
gotcha. So maybe we need to have it in terms of like minutes and seconds for coffee. Okay, so I want everybody to do this for Starbucks. And then we're going to compare, we're going to do double stem and leaf plot to Just Us coffee. We'll put on the right. Okay, so let's envision that our data goes from 8 to 29. So what kind of stem do you want to do? 0, 1, 2. So that would be 3 stems. Is that ideal? No. So what should we probably do?
0, 1.
Yep. 0, 0, 1, 1, 2, 2. I'm not worried about that first 0 because I know it's not going to have any data. All right, so I want you to do that and then make yourself a key over here to the side.
Is it like, is there a certain, like it has to be 5 in each one? Like a range of 5, does it matter? Or does it label
You
it?
want to have typically 5 to 10 stems. So how many end up in each one, doesn't matter.
Okay.
But I want
Do you have
5
to
to
label
10
that?
stems.
Do you have to label how much is in each one?
No. here's what I came up with. Make sure you have a key. Okay, so let's talk about two things maybe that we can say about the comparison between these two things. Which one appears to be faster in general? I agree, because Starbucks is going from 8 minutes to 27, while the other one's going from 10 to 29. So Starbucks appears to be a few minutes faster. Okay, Starbucks appears to be a few minutes faster. All right, now how about which one, though, is giving more consistency in the times?
Just us.
Yes, do you see how these are more closely clustered together and Starbucks is more spread out? And that's going to play into our discussion tomorrow about standard deviation. But Just Us Coffee seems to be a little bit more consistent. So if they could just reduce their time a little bit, they would be the better choice if they were just consistently a little lower. So Just Us Coffee is more consistent. All right, very good. Okay, so that is stem and leaf plots and double stem and leaf plots. Now let's move on to our last thing, which is dot plots.
Oh, we have to do that.
So here we go.
Oh, this looks easy enough.
Yes. Now, I actually don't like this first picture of a dot plot, and I'm going to switch it up in my information for next year. So let's just first, from this picture up here, talk about some benefits to using a dot plots instead of stem and leaf plot. What do you think by just putting dots in the bins, what's good about that? Okay, now as far as you can see how many more numbers there are, you can also see that in these because, you know, if you turned it sideways, you can still see how many numbers there are in each.
Faster to read because like there you have to like correlate.
Yes, it'll be quicker to make because you do not have to put things in order in the bins. You can just put dots. You don't have to look and put it in order of 2, 2, 3, 3, 4, 4. Okay? So it's definitely quicker to make. But what is a disadvantage?
It's less
It's less precise. Very good. You cannot see the individual pieces of data. So that is a downfall, not being able to see the individual pieces of data. Now, the thing that I don't like about this one up here is that technically we want to put things in a bin just like we have done with a stem and leaf plot. So I'm going to demonstrate that with this set of data here, okay? I think that would be better. So this is football. Apparently the football freshman team took tabs over the whole entire summer of how many bowls of ice cream they ate. So I'm sure they didn't come on the first day knowing this. Maybe they knew they were going to keep track of it. It was a summer assignment or something. I don't know. But let's talk about how we might organize this data. So first, we want to put a
88 bowls over the whole summer.
yes. So we got number of bowls of ice cream. So that's what we're going to be plotting. And so what's our numbers going from so I can tell how many bins to make?
It looks around like 40, 34 to 88.
I see a 93.
I see. Oh my.
Okay, so I'm going to do railroad tracks and so that I can jump straight to the 30s. If I'm going from the 30s to the 90s, how do you want to make the bins go to have 5 to 10 bins? Do it easy. 10. Yep, let's do it by 10. So I'm going to start with 30 and make my bins go by 10s. Yes, it does.
Oh my gosh. Vanessa.
It rhymes.
You're a
Imagine
poet
that.
And you didn't know it.
Yep. Okay. That's right. That's how a lot of the songs start, is I'm sitting there just talking in class and what I say rhymes, and I was like, okay, make a song out of that. This is because I'm not starting at 0. And jump, yes. Okay, now over here on the side, we're going to do frequency. Because what the frequency is means that I'm going to put 1 dot and 2 dots and 3 dots, or however many dots are going in the bin. Okay, so this is the count of how many are in the bin. All right. Yes, you can go by twos. All right. So I'm going to demonstrate. I'm going to start putting the first one. Oh, this is interesting. Now look at this first number 40. Let's talk about what bin that goes into. Because I actually I'm not going to put things right on top of this number. I want to put it in a bin. So this bin that I'm talking goes from 40 up to 50. So I actually want to put this dot in that bin right there. Okay, do you see that?
I'm confused.
I do not want to put it right on the number 40 because I'm going to have, that's why I don't like the picture up above. I want to put it in the bin that goes from 40. This bin goes from 40 up to 50.
I get it.
And so then the next number is 66. So I'm going to put that in this bin right here that's going from 60 up to 70. Okay, and do you see how I'm keeping those level? So that's that. And then the next number is 43. So I'm going to put that in that bin from 40 up to 50. And so I can just drop things straight away into the bin, making sure that I keep things equally spaced.
Did they have to match up like the first dot?
Yeah, what about, why is 40,
frequency?
what's the point of putting the frequency?
Yeah.
Because this is, see, look, see this right here? That's my two dots, see?
Okay.
So it's just to see how many dots are in there.
Yes, the frequency on the side counts how many dots go in that bin. Yes. Okay. And then I got 77 goes here. Yeah, so those aren't meaning you put a dot at like 7 and then up to 7.
Okay.
Yeah,
What about
that's
50?
okay. So let me put my 52 on there real quick. So my 52 would go here. Okay, so let's talk about 50. 50 is going to go in the bin that is from 50 up to 60. So that is right here in this bin. So see, that's the 150. So essentially, it's going to the right. Once you see 50, it's in that bin to the right. Does that make sense? Okay, so put the rest of those in there. And, you know, we don't have to do all of them. I'm just going to do I'm going to do 2 rows worth. And then you can... Do we always have to mark when what? No. This was just for teaching purposes only. That 50 being in red was just to demonstrate that if it's on the line, it goes to the right. It goes in that bin to the right. Okay? All right, so you don't have to have those all in there. That's just the first row of data. Okay, so aren't those going a lot faster, though? Dropping them into the bin rather than having to order them. No?
No.
It's not? Now, do watch out. Do you see how I'm making these all level so that the frequencies will, you know, I'm making all the dots be equidistant and stuff? So that's kind of tricky. You do have to watch that. Okay, that is the end of what we are learning today. So your assignment is pages 5 and 6. And then in class, so your homework is just pages 5 and 6. And you can finish that right now in class. I also want you looking over your tests because in about 10 minutes or so, I'll come around and take up 2 tests and your Scantron, okay? So let me give you time to look over those. 2 tests and your Scantron.